Right now, beneath this city, something is moving. Above ground, the morning feels ordinary. Sunlight reflects off glass towers. Traffic lights change on schedule. A barista slides a cup across the counter. Kids hurry across crosswalks with backpacks bouncing behind them. It feels stable, predictable, safe. But miles below the sidewalks and steel foundations, two massive slabs of earth are pressed tightly together. They haven't moved freely in decades. Friction locks them in place while tectonic forces continue to push. Millimeter by millimeter, pressure builds. Scientists monitor it around the clock. GPS stations detect subtle shifts too small for anyone to feel. Seismic sensors record faint tremors, tiny fractures deep underground. Data models show increasing strain along a major fault line, the kind capable of reshaping cities in minutes. Nothing dramatic has happened. No collapsing buildings, no sirens, just silence. That's what makes it dangerous. When rock can no longer withstand the stress, it won't crack slowly. It will rupture violently, releasing years, sometimes centuries, of stored energy in seconds. The surface will shake, roads will split, power will fail. And for everyone living above it, the moment will arrive without negotiation. The question isn't if, it's when. Beneath the surface of the world, you see every day lies a system so vast, so powerful, that it reshapes continents, raises mountains, and erases cities. The ground beneath your feet may feel solid, permanent, unchanging, but that stability is an illusion. The Earth's crust is not one unbroken shell. It is divided into enormous slabs of rock called tectonic plates, each one tens of miles thick and thousands of miles wide, drifting slowly over the molten mantle below. They move constantly. Not fast enough for you to notice, not fast enough to feel, but always moving. In most places, these plates slide past each other quietly, like giant ships crossing a dark ocean. But along certain boundaries, movement stops. The edges catch, rock presses against rock. Friction locks them together, and when that happens, motion doesn't stop. Pressure starts. For years, decades, even centuries, the plates continue trying to move, but the fault line holds them frozen in place. Stress accumulates deep underground, invisible and silent. The land above remains calm. Cities expand, highways stretch, skyscrapers rise. People build lives without realizing they're standing on a locked geological spring. Two of the most closely watched fault systems on Earth lie along the western edge of North America, the San Andreas Fault and the Cascadia Subduction Zone. These are not small cracks in the ground, they are continent-scale fractures, massive boundaries where tectonic plates meet, resist, and strain against each other. Along the San Andreas Fault, scientists track movement using ultra-precise GPS instruments anchored into bedrock. These sensors don't measure inches, they measure millimeters. And what they've recorded is subtle but significant. Sections of the fault are shifting, bending and storing energy instead of releasing it. The plates are trying to slide, but something is holding them back. That might sound insignificant. After all, what danger could come from movement you can't even see? In geology, the smallest motions often signal the largest forces. Think of it like bending a thick steel bar. At first, nothing happens. You apply pressure, and the metal resists. You push harder, and it still refuses to break. To an observer, it looks stable, unchanged, unmoved. But inside the metal, stress is spreading through its structure. Molecules are straining, bonds are weakening. The bar is storing energy, silently waiting for its limit. Then, without warning, it snaps. Not slowly, not gently, instantly. All the force that built up over time releases in a fraction of a second. The break is violent, loud, final. That is exactly how an earthquake begins. Deep underground, Rock behaves in much the same way as that steel bar. It bends under pressure. It stores strain. It holds until it can't. When the accumulated stress finally overcomes friction along a fault line, the locked plates lurch past each other. The rupture travels at miles per second, sending shock waves racing through the crust. The ground above shudders, rolls and jolts as energy that built for centuries is unleashed in moments. This is why scientists pay such close attention to strain patterns. They aren't just watching for movement, they are watching for resistance. Because a fault that moves freely releases energy gradually. A fault that stays locked is different. A locked fault is a loaded system, and loaded systems don't stay quiet forever. The Cascadia Subduction Zone presents a different but equally serious threat. There, one tectonic plate is being forced beneath another, diving slowly into the mantle in a process called subduction. The descending plate doesn't slide smoothly. It sticks, pressure builds. The upper plate bends and warps like a flexed ruler held at both ends. Geological records show that when this boundary finally slips, it doesn't produce a moderate quake. It produces megathrust earthquakes, some of the most powerful events the planet can generate. The unsettling truth is that all of this is happening right now. Beneath cities, beneath forests, beneath highways and homes. The forces are active whether people notice them or not, because underground silence doesn't mean safety. Sometimes silence means pressure is still building. Over the past few years, instruments buried deep in the earth have been picking up signals most people never hear about. Not headlines, not breaking news alerts. Just patterns. Subtle, persistent and unsettling. Seismic swarms have increased. Not one large quake, but clusters of smaller ones. Dozens, sometimes hundreds. Tiny fractures snapping miles underground. Individually, they're too weak to cause damage, too faint to feel, but together they form a pattern scientists watch closely, because swarms often mean stress is shifting along a fault. Microquakes, deep tremors, slow creeping movements where sections of a fault begin sliding almost imperceptibly instead of remaining locked. To the average person, that might sound reassuring, movement releasing pressure. But in some cases, it's the opposite. It can mean strain is redistributing, transferring force to another section of the fault that isn't moving at all. And that's the dangerous part. These aren't the main event. They're the signals before it. The Earth rarely announces a major rupture with a single dramatic warning. More often, it murmurs first, small adjustments, subsurface groans, geological whispers that something below is changing. Scientists study these signs the way meteorologists track pressure before a hurricane. Not because they guarantee disaster, but because history shows they sometimes come before it. Before the massive rupture off the coast of Japan in 2011, instruments recorded unusual seismic behavior in the region. Nothing that clearly predicted what was coming. Nothing that forced evacuations. Just anomalies. Patterns that, in hindsight, looked like early tremors of a system approaching its breaking point. Then the fault slipped, producing one of the most powerful earthquakes ever recorded, a magnitude 9.0 event that shifted the seafloor, launched a devastating tsunami, and altered Earth's rotation slightly on its axis. Decades earlier, in 1989, California experienced a different kind of lesson. The Loma Prieta earthquake struck without warning during the late afternoon. Highways collapsed, sections of the Bay Bridge failed, buildings pancaked, power went dark across entire neighborhoods. It lasted seconds, but the damage reshaped infrastructure planning for generations. And before it struck, the region hadn't believed a major rupture was imminent. That's the pattern that unsettles researchers most. Major earthquakes don't wait for perfect timing. They don't care about preparedness levels. They don't care about population, density, traffic conditions, or whether emergency systems are ready. Stress builds according to physics, not human schedules. And when rock reaches its breaking point, the release isn't negotiable. It's automatic, it's instantaneous, and it's unstoppable. Imagine standing on a city street when it happens. At first, maybe a vibration, like a heavy truck passing. Then the ground jolts sideways. Glass shatters outward, asphalt ripples. Streetlights whip like branches in a storm. Within seconds, structures never designed for the lateral motion begin to fail. Highways buckle and drop. Power grids trip offline in cascading failures. Water mains split beneath intersections, flooding streets from below. Cell towers overload or lose power, cutting off communication when people need it most. Emergency services are stretched instantly because the shaking doesn't damage just one block or one neighborhood. It hits everything at once. Every building, every road, every system built on the assumption that the ground would stay still. And the most sobering reality isn't the destruction itself. It's the location. Many of the world's largest cities sit directly above active fault systems. Millions of people live, work, and sleep on terrain that is, geologically speaking, temporary. Beneath their foundations lie boundaries between tectonic plates, places where pressure is constantly accumulating, even when nothing seems to be happening. That's what makes the silence so deceptive, because when a fault line is quiet, it doesn't always mean it's safe. Sometimes it means it's waiting. And somewhere beneath a major city tonight, instruments are still recording tiny tremors most people will never feel. Scientists are still watching their monitors, still analyzing data, still asking the same question they can never fully answer. How close is the system to its limit? And what happens when it finally reaches it? For most of human history, people feared what came from above. They watched the sky for omens and disasters, dark storm fronts rolling over the horizon, fire falling from the heavens, lightning splitting the night in blinding flashes. The dangers felt distant, dramatic, visible. Threats announced themselves with thunder and warning signs. But the greatest forces shaping our world have never lived in the sky. They live below us, beneath streets and skylines. Beneath oceans and continents, the planet is always in motion. Not violently, not suddenly, just persistently. The ground we trust as permanent is actually part of a slow, restless system that never truly stops shifting. Every second, tectonic plates press against one another with unimaginable force, storing energy deep within the crust where no human eye can see it. On the surface, life continues as if nothing is happening. Cities expand, bridges stretch across bays, towers rise higher each decade, engineers reinforce structures to sway instead of shatter. Scientists install sensors into bedrock to detect the faintest tremor. Emergency teams rehearse scenarios they hope never come. Humanity prepares, calculates, adapts, but preparation has limits. No technology ever built can stop a tectonic release once the threshold is crossed. No machine can hold continents in place. No system can switch off the physics of a planet. When the stress exceeds what rock can bear, the release is absolute. It does not hesitate. It does not reconsider. It does not grant warnings on human timelines. The Earth doesn't panic. It doesn't rush. It doesn't need to. It simply builds pressure, year after year, century after century, storing force in silence until the moment friction fails and motion wins. And when that moment comes, the shift is not gradual. It is sudden, decisive, and irreversible. Seconds that redraw maps, seconds that rewrite histories, seconds that separate what existed before from what exists after. Somewhere tonight, beneath a major fault line, that process is still unfolding. Pressure is still accumulating. Rock is still straining. Nothing on the surface reveals how close the system may be to release. And one day, whether soon or decades from now, that stored energy will find its way out. When it does, the world above will feel it. Because in the end, preparedness is not panic. It's survival.